My name is Chase Atherton. I'm the project lead for the 49er rocketry team, and I'll be going over this year's Expo poster. So as you can see here, we have our poster for this year, going through our vehicle designs, our payload designs, some of the code that we use for our payload, and as well as the requirements for our project. This is a NASA-run project that we compete against about 60 other colleges. We have some success criteria that our team's trying to hit to ensure successful performance. So here we have our vehicle breakdown. So we have our full scale and our subscale vehicle. Our subscale vehicle is what we build first to prove to NASA that our designs are sound and all of our simulations are accurate. Once we have successful flight data from this, we move on to building our full scale rocket. For this year's competition, we did a 60% scale subscale, so our total length for our subscale was about 59.5 inches, and our total length is 100 inches. Our target altitude that we determined in our preliminary design review that we turned in November 1st was 5,000 feet. This cannot change for the remainder of the competition, and we must design around hitting this altitude. Whereas our subscale, the altitude doesn't really matter, but based on our past flights, we went 3,058 feet, and our data lined up pretty well with the simulated. And then we have our recovery plan over to the right, and then in the bottom left, we have our booster assembly. This is basically how our motor is retained in the rocket. So here we have the payload for our project. We named it Anvil, or Autonomous Vehicle Imaging Localization. The payload must be able to autonomously locate the landing position of the vehicle and transmit that location to the ground station, all without the use of GPS. So our solution to this was Anvil, using a gimbal system to stabilize the camera. We will use the camera to map images against one another for locating the position of the payload. This will be constructed out of 3D printed material, and it runs off a Raspberry Pi 4, which you can see here, and you can see on the bottom we have our gimbal system. Up in the top right, we have an example of our camera vision code. It is coded in Python. It maps images against one another at varying heights, and it determines the location based on those mapped images. And finally, we have some of our supporters. So we work with NASA. North Carolina Space Grant, they provide us with funding, and Siemens, they provided us with a bunch of their software. So yeah, and that's going to be all. Thank you.